check the check. Mike chickadee, check the Chinese chicken. Yeah. All right. Setting up a little bit of coding today. I've been doing survival games for a bit, and I'm kind of craving some code. Now, we're gonna do it special. Now, if you know coding, you know coding. So you're gonna learn a little bit of a fictitious programming language. However, call it fictitious, but also call it abiding by the typical forms of code programming. You see, in computer science classes, when you're in university level, one of the logic and organization tasks, assignments, if you will, projects, actually, is to create your own compiler for your own custom programming language. So, you know, give it a name, do something with the process, but the logic is still there. Create your own. I mean, if you've ever seen, wait, hold on. You ever seen LOLCODE? You ever seen that sucker? LOLCODE. That exists. This is a language. Let's take a look at LOLCODE real quick, because I haven't seen this in a while. A smiley face represents a new line. The super smiley face is a tab, represents a bell character. Hi is how you start it off. Ken has Ken has stdio. This is how you import other packages. Visible hi world. I mean, that's just a string, but they just spelt it that way. And then K thanks bye. This was someone's computer science project at some point, and it is its own language. Now, you can have a language. That's fine. But what makes the power of a language? What makes the ability for someone to have, I guess, more skills, more tools, more dynamics in their coding? It's not the language itself. It's the library behind that language. It's what's available, right? This is kind of like it's cute. Hi 1.2, Ken has stdio, standard input output. Please open file lolcat.txt. I like that though, actually. Awesome. Thanks. Visible that file. Oh my God. Oh noes. I guess this is like try and catch. Yeah. Awesome thanks is try, oh noes is catch. But that's the thing, right? Every language still abides by the typical logical structure. It doesn't matter what you name it. It's like a variable, a very big variable that basically deducts what your language is going to look like if you make your own compiler. But it still follows base rules. You need variables, things to store data in. Functions, you need code blocks that you can repeat and call upon with a quick word or name, a function name. Ken has studio. I has a var. I has a var. What is the var though? Is that how you declare a variable? Do you have to put I has a var every time I have a var? I'm in your loop. Up var. Oh, okay. I guess var is the name of the variable. I has a is declare. Because then up var would be like a var plus plus increase visible var. You'll be basically printing that on the console. Is var bigger than 10? Okay, thanks. I'm out of your loop. Okay, thanks, bye. It's cute, AF, but I think I'd probably get very annoyed trying to like program with this. So we do this all the time. As a computer science major, as a computer science minded individual, we essentially use the logic of programming. It does not matter what your words are for doing the thing you're doing, as long as you're following the typical forms. And we're going to go over those typical forms in, ooh, excuse me, in GreyScript. That was my coffee. It said hello. So we're going to go a little bit over the visual forms, what I like to call the 15% of all programming. If you know this 15%, you will know programming. And then you can learn other languages just by adjusting the way you normally see those. And I kind of wanted to make a little project because I'm growing within this uh game system here, the simulation. So I'd like to kind of like organize my code and my files and my abilities. So I need a couple of things. Oh, no, I was doing the wrong screen share. ¿Por qué, Maria? Why am I so dumb? Okay, let's see that again. Uh, Lol code. Just for the record, right? Lol code. Oh my God, why'd I do that? I'm so bad. I'm still waking up. I'm sorry. If you just got here, if you've been watching and you left and you're like, what the hell is this guy talking about? He's not sharing his screen correctly. Yes, that does happen. That does sometimes happen. That's why I'm looking at chat too, just to make sure the more people to join and can call me out on stupidities, better things work out. So there's your low code. There's the high 1.2 version, I suppose. Ken has stdio. Visible high world. Okay, thanks, bye. So your typical forms of importing Ken has Studio. Oops. And then printing, right? So you got a printing ability in basically every single language. You can open a file with this. I think that's actually nice. Please open file. That's very what's the word? Polite. Please open file, thanks. And then awesome, thanks. And then can't it. Okay, thanks, bye is probably the best way to end the program. I'm gonna basically say here. So yeah, this is low code. But we're going to go through the simplistic, the 15% of programming that exists in every language. I basically go over that. Um, God, what was my... I have this in my code space here, or my code playlist. Uh, Hello. Is it me you're looking for? That shareable link. There it is. Yeah, the mystifying programming part one, the mystifying programming part two, and part three all focus on three different languages. Or was it just one for this one? Hold on. There was a 3D one too that I did. It might be that one. Let me see, Scholar. Yeah, in this course we look at the significant difference between C++, Python, and JavaScript. That's it. And it's not like it's a huge course. It's not like it's going to be like 50 hours of watch time. I go through the bare bone concepts. Once you understand the bare bone concepts, what a code block is, how we represent code blocks in Python, in C++, and in JavaScript. Hint, two of those are very similar. Then you start to understand the general format, how variables are set up, functions, loops, all the pieces in between, right? So if we were gonna go straight forward right here, let me do something real quick. Unresponsive browser. What are you doing, browser? Oh, brain. I'm still waking. I'm still waking, so I'm gonna take my time here. If you're watching after the fact, feel free to jump around on the timeline because it's a slow start, slow burn, but once that fuse lights, man, we're gonna be going ham. Um, okay. Why'd all that close? Oh, you know what? Hold on. It's a little quiet right now. Well, actually, no, it's not. I have to move my. Yeah, there we go. I have to move my headset over. Ah, the music's gonna wake me up. Give it a moment. Give it a moment. The energy's popping in. I hope you're having a good day today if you're chilling. Let's see. All right. So, Those are the videos. Take a look at them if you want to take a gander at the overall aspect of things. However, I got myself set up. I got the chat. You want to say something, say it up. If you don't, stay quiet. It's cool with me. Also, like and subscribe if you want more content. If you're not already, if you are, appreciate you. Appreciate you much. All right. So, first 15%, right? We're looking at every single language that shares these things. Call it the first 15% of all languages. Got var. Now, the case is, am I going to be calling it var here? Probably won't. But I can basically state something like this var number equals 5. This should be fine in the case here. Some languages need you to say what it is. Some will just guess automatically. Low level, like C++ and Java, you got to make sure you tell it. It's an integer, it's a number, it's a string, a bunch of characters that I'm putting together, or something with a different size value. Then we've got arrays. This is a set of values that we basically go through on a single name convention, right? This variable. We can basically call this variable at any case and point, and it may hold more than just one thing, which is the great thing about creating collections. We have collections and folders. When you go into a folder and it's your images folder, I'm pretty sure most of your folder stuff is images, right? So we tend to like to collect data together that's relative, and we'll put it into a single variable. And in this case, I can do 5, 10, 15, 20, 25, 30. Oh, I basically put the 5 multipliers in there. We've got dictionaries or key value arrays, which I'm not sure how to do yet. So this is where I'm going to actually go into uh, documentation. So if you ever do want to I've been getting this a lot lately, and I'm actually going to start using this a lot more. GreyScript API. You want to learn a language? This how you do it right here. Read, 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 read. Um, someone look up array. Probably not gonna find. Come on. Methods general, detached. No, that's detached. Dictionary. No. Variable. See, they're not gonna give me the basics here in this. Okay, so then maybe I can go into manual scripting basics. All right, fine. Oh, look, they have their own custom manual. So let's check that. Strings, lists, maps, type checking, and extending build-in types. I don't see arrays in here. Fizz, buzz. Ooh, I like those. Oh, I love examples. All right. Yep, fizz, buzz, function. All right, so we got functions. This is an interesting one. Which is this the only way we create functions? That's very JavaScript. Small programs that do interesting things. Fizz, buzz. I remember that one was a computer programming class. Control flow. Basically here, right? Yeah. Where's functions? Let me see the ways, because sometimes it's more than just one way, but no. No. This is the way we declare functions in just one swoop. So we basically create this function name. Again, the naming convention here is completely custom. If you're not used to how to name variables, it's basically whatever comes to mind. You're calling them as a custom name for that data you're putting in. Equal sign is basically your input. There's a language called R, and I really like the way they use the equal sign because they do this. They do like a arrow with an equal sign, and it's very much logically deductive. This goes arrow into this. So technically, when you see a equal sign, I really do like how our programming displays that idea logically. You're looking at storing whatever is on the right into the left. It's just a complete, and variables I like to think of them as boxes. Boxes of information. You got to label because you got to make sure you know where the kitchen is, where the living room is, where the bedroom is, bathroom. You don't want to mix those together. And the label is our naming convention. It's this little detail here. This var array. I can set this as kitchen if I wanted to. It's completely custom. So that's always good to keep in mind. The more detailed you are, the more, well, the less lost you're going to get in your own code. But I'm going to remove those little arrows because that's not a good formatting form here, right? Now, I like this, honestly, being that if I wanted to create a variable, I put the number there. If I wanted an array, I put the array which is in brackets, right? Remember that brackets are a big part in arrays. And if I wanted a function, that's what I do, really. Let's put input here, and we got to make sure that's the case here. And then we go to the next line. Got to put a tab, and then we do what? Print input, and then end function. Really? That's it. That's it. So we're basically making it super simple. Now, hard to see in this example. This is why I like to use so really if you want to get a good understanding of Python, JavaScript, and C++, really the mechanics of code blocks, those curly braces really do help to really understand it. Because when we look at this, we don't have curly braces. Sure, we have function and end function. That's kind of a given. We're seeing that. Hello, I think the sun is a hologram. Yeah, I think so too. We're all living in the Matrix, my dudes. What's going on, peeps? What's going on, peeps? Text is not clear. Thank you for that. Let's see. Well, what part? Potentially. Try to update well, maybe I should check on the stream itself. Try to update the quality. Give me a second here to make sure everything's running smoothly. Ooh. Well, what? 720. You right. Hold up. Yeah, okay. That's a little bit. Ugh. Why is that? Well, it depends on the text too and where it's at. Because that text on the web page or on the YouTube video. But then that's the YouTube video. Hold on, let me go back to here. I want to make sure it's clear for y'all. Give me this. No, 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 no. It's cool. It's cool. I think it was the text from that screenshot here. Like you're not gonna see this tiny text, but this is a video again that I have hosted. Just look up Demystifying Programming Part 1. Yeah, that text is not clear, but this one's fine. This one looks good. This one looks good. We can see perfectly fine. And if you don't see good, make sure you're doing the 720p resolution. Text gets tiny, so make sure you're using the highest quality when you're looking at tiny text. I'm not gonna do tiny text, but how's everyone doing? Thanks for joining in. Chit chat away as we go forward. Ask any programming questions too, or about the sun being a hologram from the North Pole. That's a very specific location. Why not the South Pole? You know what I mean? All right. So we've got arrays, or sorry, variables, regular single variables. And again, we can say this is a string equals to hello. This is a number. Again, the naming convention completely custom. Don't forget to save if you're making some actual coding stuff. You want to make sure that uh, my first steps, first 15, I call it first 15 dot source. All right, save your code. Say, Control S is your friend. I have to teach every one of my students that pressing Control S is a lifesaver because you never know when shit's gonna break. You do a loop. If you're doing Python, you're probably okay. If you're doing Chrome and JavaScript, you're probably okay. If you're doing C, C++, sometimes Java, and you make a loop and you didn't stop that loop, and all of a sudden your computer starts to slow down depending on the level of RAM and stuff that you have, you're probably in for a surprise because you're probably going to have to restart that sucker completely. So save your stuff as you go. I like to save basically with every line I put in. And it's just a tick, a habit. Control S, Control S, Control S. That's all I do. Does this work here? Control S? Nah, it actually doesn't work in this little simulator. So unfortunately, I'm gonna have to press that save button every so often. That's my kryptonite. Achilles foot, heel, whatever. So this is essentially it, honestly. Starting from this point, we know how to store data. We don't know technically how to show that data just yet, but we have the ability to grab information, save it, and then organize blocks of code. What we haven't talked about yet is control structures. right? So this is probably like 5% out of 15. Then we've got if branching, taking logical steps and trying to figure out which direction, which path we're going to take. So if is always the case for a true or false check. So if something, I don't know if I can use parentheses here, but I'm gonna try it out, then do the thing. And then end if to end the GreyScript space. Again, much nicer with curly braces, so that can essentially make a big difference with understanding. But in the end, we are looking at this sort of concept here. We're looking at I don't know if I can zoom in, but the code block is what we're trying to identify with these. Code block begins at the statement here and ends at this location. And that's the important bit. Same here. Then, and then end if. So the code block is really just whatever is in between these spaces. We save these code blocks. They are organized based on particular form, and you can put as much code as you want. I've just put one line for now, but we're going to kind of expand on it. And the focus here, we're not really doing like programming like C++. That would be really hardware specific. We're really doing more like shell scripting. If you're on a Linux system, if you're on a Windows PC, it's batch files on Windows PC. That's normally how I would set up my Minecraft server is to create a batch file that activates the server at a specific resolution with specific Java versions, and it's basically just one line of code. That's it. But these script files essentially control the computer from its basics, right? You can create batch files for Windows or shell scripts or bash, BA shell, bash scripts in Linux space. So we're really more in the Linux space. When we are looking at GreyScript though, or Grey Hat, you'll find really weird things like EXEs for whatever reason. Like here's your typical terminal in Grey Hat. You got a scan LAN to look at your local network. It's an EXE. I think it's trying to basically stay executable without it trying to be so close to what an EXE is in Windows, because we're not in Windows. How do we know we're not in Windows? We go up a couple of times. We go to the root, which is a slash. That's a Linux structure. In Windows, the root is the C drive, C:/. In Linux, it's just a straight up slash. So we know we're in Linux. We've got a boot directory for the actual booting process. We've got the home for the guest and my username, the user space for all the binaries in that space, mail.exe, map.exe, etc. Again, exe is a Windows naming convention, but if you're doing Linux, what is their naming convention? It's just bin for binary in most cases. They do have custom forms of packaged pieces. And if you think of programs, what are they? They're just a bunch of zeros and ones, right? They're basically running through a binary execution. That's what a bin or bin or executable is, zeros and ones in binary. So an exe technically wouldn't even be binary. I think I can actually give an example here. If we open up, let me go to my average boy backups. Let's say we open up something like a speech platform. I should be able to open this up with zip portable. Look, holy crap. It's a MSI, it's a installable package, but holy moly, it's got stuff inside. That's it. That's it. It's not like it's just one file. EXEs are not just one files. There's XAMPP for Windows. I opened that up. That's why I love 7-zip. It opens up anything. Also a set of files. Now it makes you think, what is an EXE but just a packaged set of files that work together to create an application? No one really knows this part or really dives deep enough to open it up in an archive and see what's inside. So any type of EXE, I can probably open this one, but this one's 3.5. This is my CUDA my Barracuda. I actually have a little script here to create some music using the Facebook Music Small Gen. It's pretty decent. It needs tweaking, needs some tuning, but it does a pretty decent set. So this one, let's say, this is actually real computer now. This is not gray hack. Uh, Duration, let's do a 30-second track. Let's see what it sounds like. So I'm gonna save that, get out of this. Now, if you're doing AI programming, a little bit different, right? Being in Python here, we're essentially using Python as our main interactive language. And the AI model, in this case, the Facebook Music Gen Small, with some tools from Python imports, audiocraft models, basically things that we import from another library. So again, what makes a language powerful? Is it the code? Is it the way we handle the code? Or really, I think if you really know a little bit about the universe of JavaScript, there's this Node.js library. It's its own server-based system. Node.js, just like Python, they're one of the strongest programming languages because of the packages or tools available. What we would call the other 85%. So if we talk about the 85%, because up here is the 15%, the other 85% is basically all the imports. I'm not going to really list them here. Package imports. You can do anything from here. Game design, security networking, um, image editing, music creation, AI control, data manipulation, server creation. If you want to make your own web server, you do it with this extra extended library, right? So that's the power of a language. It's not that it runs on hardware or it runs in a Python runtime environment. It's what can that language do technically? And as mathematicians, in a way, you don't have to be a mathematician to be a programmer, but I see a very big kind of parallel with mathematicians and programmers is we're both lazy as fuck. As fuck. If you have a math problem, I will try to solve it with the most cheats possible because I'm going to get to the answer and I don't care about the process. I just want to give you the answer so I can prove you wrong or right or whatever, right? I'm in a teacher situation. So I will do all the little tricks of the trade of math and manipulating of numbers to get the answer right. That's the stuff I teach my students so they can do mental math without having to write stuff on paper. They're able to take the tricks that I know as a mathematician and just basically get to the answer without having to do a lot of thought. Programming, same thing. Programming, we would like to do as much as we can with writing the least amount of code. That's it. We just kind of lazy like that. That's the power in it. That's the power in programming with a specific language that has those 85% imports. So what is the 85%? Well, it depends. If you're a game dev, you're going for 3D graphic imports. For Python, for instance, you probably have a gaming library like Pygame, right? If you're in Pygame for Python. Uh, if you're a server dev, you'll be using sockets. If you're a data analyst, you'll be using Torch. Those are all imports, or you'll be importing. Let's call it import. You'll be import Torch. You'll be import socket. You'll be going for import 3D graphics, or in this case, import Pygame. So those are the kind of diversities when it comes to the later stages. After you get the hang of the first 15, you just expand to whatever interests you. It doesn't have to be like everything. You're not going to learn all 85%. You're going to master the first 15. And then the other 85 is basically just going to come with experience. Now, further in, we're looking at if and then statement. So this do the thing. Let's kind of get back on track on the 15%. Now, there's choices and branching of choices. If this thing doesn't happen, we have another case scenario. If uh, above false, then do this. So again, and I want to check here. True. Okay, true works in there, but let's say we do 2 equals 2, right? Let's also build this. We can actually build and save. Let's do compiled here. First steps. Go to my executable. Print input. Okay, so one thing I didn't do is I actually called the function. So we create actually a good important part here. Sometimes I make mistakes. So GreyScript, right? GreyScript is a language run in a simulated environment here in Grey Hat. Grey Hat is a hacker simulator. So if you want to take a look at, for instance, a couple of details, we can go into the current network that I'm in. And from here, I'm currently on this little server right here, right? Device details, that's me. And from there, I'm able to use programming with GreyScript to create automated scripts to get into other devices, exploits, networking. So that's basically what we're doing. In the case that, you want to play this game, but also if you're just curious about programming. Because what the hell is GreyScript is one scratch of the surface. We're really asking what the hell is programming? Because again, if you're just joining, cool. We're looking at the basic 15% that all languages contain. And if you really think about it, I mean, I don't know if you're a computer science major, maybe you are, maybe you're not, but maybe you don't know. The final projects in computer science in university is to create your own language. So maybe this was GreyScript was a uh, pet project of an individual that decided to make a whole game off of it. He just created an assembler that will compile his own language. And then from there, basically, he was like, hey, I can make a hacking game, so I'm going to use this form of programming. I would say GreyScript is very similar to a Python-esque type of programming language. Very Lua, actually. Actually, it'd be more like Lua. If you do Roblox programming, you know that Lua is the main language there. Heck, if you play League of Legends, the client is Lua. I'm probably going to say most game clients are Lua based, but it basically looks like the same, right? So, why didn't anything happen here? In my first steps, I didn't execute, but nothing happened. At the least, I should get a print, some information popping up. So the issue is I've created this code block, but I haven't activated it in any form. How do I activate? Basically reuse the name. And I believe I got to use this guy here. The parentheses to activate the function. All right, well, I'm just gonna type it in manually. Null input. Ah, we don't have an input. Fair enough. So let's say we put in, this is the input. So that's the steps. You write code, you compile it, you run it. There we go. Finally got a response. So now we're noticing a couple of things before I actually put anything in the parentheses. Because in this case scenario, beginning programming wise, we're looking at this input being a value we have to enter. When we create a function with the case of, hey, I'm expecting something to be inside of this parenthesis. In fact, I'll extend this a little bit higher. If I create a function with an input in this variable called input within the parentheses, then I should also correlate the fact that I'm calling the same function name down here. There's the function name, and there's the call. The first case, though, this is called the uh, constructor, in a sense. Not even constructor. This is the declaration. I declare this function exists. But this one here is the activator. I activate the function that I declared. Horrible mouse writing, excuse that. So it's always a case of two steps. Now, many times when you're using, you know, your own code, your own functions, you will have to create the function first, then activate it whenever you need it, really. But many times you start seeing like print. If you haven't noticed yet, print is also a function. In fact, it's a function in blue text. That case scenario, it's actually a predefined existing function in the language itself. We didn't have to create that. We didn't have to declare it. We didn't have to write any code for it. Somebody already did. They put it in the main package, and then we can use print anytime we want. With that case, we're really looking at what is a built-in function and what are custom functions. Well, custom functions are when we create them here in the declaration space, and then when we activate it on some line later. That's it. Built-in functions, they exist already in there. All you have to do is basically go through this. Yeah. For GreyScript specifically, right? If we go through, boom, here's a bunch of them. Add repo, APT clients, blockchain, amount mined, coin price. We can create coins, computer, file. We've got classes. We got to go over classes next. These objects that we'll be working with. Connect Wi-Fi is a function. Where there it is. Oh, it's a function inside of a object. So almost there. I'd say so far we're at about a 12, 13%. Got a couple more things to work with. Actually, call it 10%. We haven't done loops yet. So we have this function that runs all the time, and it's always going to essentially call this is the input, or this is my input, or this is the input. But this case scenario is very what we call written, set in stone. It never changes. It's not dynamic. So what do? I can use this. Let's make this the thing we do if 2 equals 2. Simple, right? We're going to take this case and say 2 equals 2 is a true factor. This is going to run. And if I do this, let's change the text here a bit. Run first instance of if, run the else. And we run this. We are running the first instance of if because we have a true statement. That's it. True statement, 2 equals 2. Yeah, I know it's simple, but it's not dynamic just yet. We've kind of hard-coded it too by putting in numbers instead of variables. The 2 and the 2, they're hard-coded. They're just values. They're never going to change. So we adjust this with some variables for dynamics. But I could change this to 3, recompile it just for the example. Now we run the else. So now because the if statement is not true, this block of code runs. We come at a fork in the road, an option for us to control what code runs based on this statement. This tells us if I'm running this block of code or this other block of code. And this kind of keeps on going forever. You can make as many if branches as you need for whatever situation. I wanted to start making a script that can basically do and compile all the exploits automatically. So given enough time, and after I do this little session here on the basic, because I'm also going over the basics because I don't know GreyScript. I just started playing this game. Well, I've had it for a while, but I started scripting in this game not too long ago, maybe 2 weeks ago. But again, I'm kind of reusing the same knowledge I know from Python, PHP, Lua, JavaScript, C++, C Sharp, and Unity and stuff that I've played with before. Basically, everything I know about languages still falls into play here. So once you know the first 15%, it basically just kind of falls into place. That's as best I can put it. So here we have the control structures. Here we have data storage. So data storage and variables, control structures and if and else statements. Then we've got maybe two more things to go over with some caveats. We've got for loops. Oh, I'll spell it right. For a situation to happen. I do want to point out some things here. What's that manual again? They didn't use parentheses in the manual. They just put x double equals to 42. Cool, great. But I put parentheses. Take a hint that I like organization. I put extra parentheses in my math, so judge me or not, I don't care. I want to make sure when my eyes are looking at it, because I got hell of a dyslexia, I'm looking at the thing I'm actually analyzing. So I put parentheses on many things. So this helps me make sense. So you can use parentheses or you don't have to, because obviously the manual says you don't have to. But how did I know I could use it? I just tested it out. In most case scenarios, you, in Python specifically, that also kind of has a bit of a, yeah, you can use parentheses or you don't have to. It's up to you to figure it out. So I'm gonna use parentheses whenever you see it, but potentially you don't have to. The manuals will be specific on the details. Okay, so let's figure out looping for. There we go. So if yes, we just went for. There we go. Ah, this is very Python. Okay, okay. So for, let me see, some value I in range of 10 by 1. So we're going up by 1, counting to 10. I guess this is where parentheses can be a little bit messy, having extras. So we should do a print. Yeah, I guess I'll put it there. I plus. So what's happening here? Let's kind of take a look. We're mixing variables a bit, creating a for loop to go into a actual loop. It's going to go from, I wonder if we have sleep. Do we have sleep? Nah. Oh. It's going to go very quick, so that's going to be disappointing. But we have a value I variable. In this case, very simple. I can call this count. And I can call this count. Doesn't matter. I want to give you the idea that your naming conventions are yours and yours only. Even if you pick it up from a guide, you're able to change variables as you see fit. So we're counting. We're counting through a range of 10 or 0 to 10, counting by up 1. I want to try another format because for loops normally come in different ways. This one's a very Python type loop. There's a standard loop control like C++, Java, and JavaScript that I want to try. But for this case, this seems all right. So I'm line 22. Maybe it's the parentheses. Oh, you don't like the parentheses there. All right. I guess in this situation, no parentheses. We'll check again with another case. Yeah, it's going to run really quick. So there's the run else. We haven't adjusted anything about this truth statement. So now that 2 is not equal to 3, we're running the false case scenario. There's our counting loop. It counted very quickly, so if you blinked, you missed it. But I also wanted to check for I equals 0. This is going to be I don't know, I is less than 10. I don't even know if it increments this way. If this works, because this is a format for old school programming, thinking C++, Java, and all that. I am attaching with a plus here. Normally, when you look at pluses, you think math, but when you're dealing with strings, it's a glue. Yeah, identify 27. Yeah, it doesn't read this, unfortunately. I do really appreciate the old school loops, but I guess I'm gonna have to be doing the count in ranges and stuff like that. That's fine. That's fine. So that form didn't work, and that's just basically JavaScript, Java, and C++ for loops. So we're gonna be thinking of starting a variable that's gonna be managed by a value over time. And then we give the range function, which probably is where the actual repetition comes from, because the range gives you an array. and then this goes through that array. I mean, I could probably do this too. Yep, same thing, same thing. I started at 0, they started at 10, they went down, I went up. So basically, range really just gives you an array. Like, there's just so many little, I guess, again, programmers like mathematicians are lazy, so you wouldn't want to type in a decreasing array of 10. I mean, I can basically emulate the same thing. Let's go to 0 because I'm very intertwined with the zeros. So I can basically replicate the same range, but I would have to use this array to replicate the countdown. Fine. But if I didn't want to use this huge thing, we have shortcuts. Shortcuts aren't great because we're lazy, and we just do this. Then what if we had 100? Did you want to make an array that's 100 long? I think not. And consider IP addresses. You've got at least 255 per space. There it is. Look how quick that went. That's a good testament to the hardware I have in this computer. Pretty decent, at least. Okay, so we've got loops. We got another case for a loop. It's a while loop. We'll bring it up once in a while. Get it? Get it? But let's take a look at it real quick. Looping with while. It has a single condition. It's basically checking for a true or false. It's almost like a keep doing this until it's false. It's very much like a if statement, but an if statement just runs things once and then it's done. While is basically doing the same check if something is true or false, does it over and over and over and over. And whenever it turns false is when it's done or it ends the loop. So the problem with while is that I don't like to go into very eagerly in the beginnings is that that's where you break yourself and your computer. And potentially if you're doing C++, you might fill up your memory with junk because that would be a case where you forgot to switch the while to be an off under a specific situation and you're just in an infinite loop that continuously goes. So I'll avoid whiles until I really have to use them. But that is kind of the while case scenario. While it's true, loops forever. Oh, time. I like time. Let's see what that does. Maybe it's a built-in variable. So, you know what? For the fun of it, what this do though? Hmm? What this gonna do though? I wonder actually what it will do. Is it gonna crash the computer? Is it gonna crash the game? Is it just gonna go on forever? And let's see. Nope. Nope. There. Oh, where the hell are you? Terminal. Copying? No, you're not copying nothing. Oh, there you go. It's a forever loop. Oh, look at that scroll bar go and go and go. So we create a forever loop. Very nice. Now, I guess in this game scenario, it's probably much safer to do so. It's a simulated environment, so the developer probably created a not break situation. But you can now see it nudging a little bit because we're filling the whole screen with haze. Welcome to the infinite loop situation. How do I get out of it? Normally in any scripting environment in a terminal, Control C should get you out of it. And control in terminal is like this up arrow. So there we go. But then I want to break out of it. I want to use that little thing that I was talking about. That's something new. If the time is greater than 100, then break single line if statement. Again, lazy case programming. We want to write as little and do it more as possible. Very mathematician-like. Is this 100 seconds? 100 milliseconds? Are we going to do this for 100? No, it's gone. Yeah, it's still going. Hold on, let me cut this a little bit because I know it's gonna keep going for 100. Let's do 5. Let me see if it's actually seconds. 3, 4, 5. Not bad. I like that. I wish time was as easy as that, honestly. So I guess in this case, time is a variable that's being held by the script. As soon as the program starts, it counts, or potentially when when does that time exist? Because we don't actually start it up and activate that variable anywhere. Hmm. It just kind of works in. This has got to be some sort of internal mechanics of the game that can keep track of time. When it's being tested, it starts to count and eventually be gets tested at the 5. I'm not going to think about it too much. Again, we're kind of in a simulated environment, so there can be some values in here and details that can basically be a little bit beyond the scope of normal programming. All right, so we're basically done with the 15% of all programming languages right here. It's basically 30 lines, y'all. That's it. Variables, strings, arrays, a function to store code in, similar to variables. Variables are just single pieces of data, but functions are blocks of code that we can organize. Uh, then we've got if control statements, for loops, while loops. Now, they got one more thing. Objects and classes. This is probably the most important thing because that's how you interact with other libraries. Yeah, they're gonna give us the basic stuff. Yeah. Okay, so let's think of it this way. How do we make objects interesting? Let's make a fighting simulator. Players, two players fighting each other. So we need to figure out some stats. Makes sense. We're gonna have a player type object or fighter. Fighter player. I guess player can be NPC too, so we'll keep it player. We're gonna make a new but we have to create it. Hold on. They're using this to make it. Okay. So here I should be able to then do hit points, damage, critical, chance. I think I'm gonna be really, yeah, maybe it's a comma here for these. Compiler error, da. Let me get a more detailed set. Square, function, abs cosine. Hmm. Return, self sides, degrees, new shape. It's a very basic definition of this class. So I'm thinking maybe we have to customize it slightly different from general programming etiquette. Unless there is extended and built-in types. No. String dot capitalized. No. Well, okay. Oh, intrinsic functions inside. Yeah, I get that. All right. So, classes these seem a little bit limited here, but let's call it this way. First, we create the player class. What is a class? It's an object. We're calling it player. Next, we gotta adjust a couple of things. Oh, no, backwards. We will go and reach into the player object and we'll set something new. We create something new. So basically creating a variable, but inside of this object. So player now has hit points. The dot is the key. When you do start seeing dots, I think in PHP it's arrows, but don't worry about that unless you're doing server development. When you're doing dots in any case scenario, it's potentially saying, hey, we have a overlaying player and inside of player there's hit points, right? But then I got to do the same thing for damage, player dot damage. I don't want this comma. This was a different format here. And then player dot critical chance. Okay. So now we kind of have three stats: hit points, damage, and critical chance. We can add in defense, we can add in all these kind of formats as well. But in the end, all we're doing now is just creating a object. Next, we need to create player one equals new player. Player two equals new player. Now, player one and player two start completely equally. They've got 100 points of hit points, 5 damage, and 0.2 crit chance. We're not talking yet about items and equipping something that increases stats, but essentially, if you equip an item, you're essentially changing the stats of player. Let's say player one equips a new item, so now player one dot critical chance is equal to 0.3. We can modify that value, right? And when we think about that modification, this is probably after we pick up some staff. You can't really do critical chance with a staff. Bow, something, sword, saber, katana, whatever. Some artificial values inside that basically give us this form of adjustment. We'd have to have a little bit more detail in the class, but we'll keep it simple for now. So how do I make these two players fight, and how do I figure out who wins and who loses? Well, basically we need a loop. This time we're going to do a while loop. While player one dot hit points is greater than 0. Let's see. And player two dot hit points greater than 0. Gonna end while down here. So there's our battle scene. Player one's got hit points, they keep fighting. Player two got hit points, they keep fighting. Basic mathematics and value comparison with inequalities. Inside of here, then, we got to figure out, in this case, more of a turn-based process, right? We may even have the ability to miss, so accuracy, we can add accuracy in here. But I think critical chance is going to be the real adjuster here of who's going to win. If they had the same amount of damage without any adjusted critical, then basically they would fight each other, and whoever hit first is always going to win. Critical adjusts that for us, so randomly we get to choose a time where one player does extra damage. I'll do like a double, just a times two. I'm looking for now some randomness. Randomness. Gotta find a set of values, because right now we don't have any random values to pop for us to adjust numeric functions. Okay, cosine character, cosine sine, log, floor, range, round. Huh? No random? That's unfortunate. There's got to be a random function in here. Hmm. Oh, okay, empty. If seed equals no, returns a random number in ranges of 0, 1. If seed is not equal none, no random number with a given integer value. Oh, so that's weird. Oh, it's R and D. I thought it was an M and a D. All right, fine. So we'll take the turns. Um, hmm. It'll be a little bit more difficult to find out who's going to hit first, but let's assume player one's going to be the first hitter here, right? So we're really diving deep into classes, but in the end, really all of this is just necessary to understand what an object is, what a class is. First, classes are defined with a blueprint. We're giving these blueprints for what a typical player has: hit points, damage, critical chance. Then we're defining two objects, player one and player two, using that blueprint. We're not changing it, it's still player, right? Player is the original. Now we got a one and a two. So that's the main takeaway here. If you understand this, you're basically done with classes. Now we're just seeing how we can play around and use those classes into something like a battle, like a fight. Player one hit points greater than 0, player two hit points greater than 0. And really, it's a practice of accessing those objects and their internal values and variables, right? So here, what we have is the case for player one attacking player two. So uh, we're gonna have let's see. So 0 to 1 is without anything. So let's do player one. Hmm. If RND random is less than player one dot critical chance, so 0.2 chance of getting a critical. So if that number ends up being 0.1, 0.1.5, 0.1.9, we're going to activate the critical on player one. We're going to say player two dot hit points equals what the player one dot damage time multiplier of 2 for that critical value. If we don't get that random chance, we're going to have a regular attack. So no multiplier, just normal. So no times 2. He just deals normal damage. This is turn 1. Case scenario for randomness. What are you doing down here? Now we go ahead and do player 2. Let's copy and paste. Adjust the values. We're checking player two's critical chance now to a random value, a new random value. And we're going to change player one's hit points based on player two's damage, again, based on whether they're doing critical chance or not. And because I wrote so many lines, now it's time to check for errors. Then, oh, right, okay, forgot. Then, if, then, nice. Sometimes you actually get a pretty decent run without having to do too much checking. Oh, right, the 5 second. Hey, hold on, we gotta wait for that. Let me comment that out. Can I comment with a, nope, I gotta go manually, slash, slash. Oh no, that's not the 5 second. Hey, is it? Is it? It should have been done by now. Okay, let's try that again with a different adjustment there. Okay, well, we did basically run the game. We just didn't show anything happening here. So let's do print player two took critical damage. And then we're going to throw in the HP left. Player two dot hit points. And then we'll go down here and say player two took damage. And then hit points left. There we go. Down here, player one. So we're not really showing ourselves what's happening. We're doing the math in the back end, but the computer is not being told, hey, show us what's happening. But now we're printing everything. Key to debugging. Whenever you're debugging, use print, use console.log, use echo, use whatever form that you can print yourself some details so you can at least be comfortable that you know, all right, these numbers are changing exactly how I was thinking they were changing. Sometimes you may, oh, hold on, you may have issues where they change unexpectedly. Oh, come on. Player two hit points. So we got to change that player one hit points. So player one took damage, not critical. And then here's the finale here. If player one dot hit points equals 0, then print player two wins. Else if player two, I wonder if that's ever going to be a tie, but it probably won't. Player two dot hit points equals 0. Print Player one wins. And then else, well, if both of them are zero, other last case scenario, both are dead. End the story there. So let's check this. Line 74. 74. Without matching. Oh, right. And if. Ooh. Okay, we having the battle, but something's off. HP left 10. Interesting. So, it's working, technically, but it's also not because it doesn't even look like they're losing damage. Let's see. Am I doing this right? See if my logic here makes sense. Let's go back here to where we started the fight. Oh man, there's so much text being printed right now. Let's see. It's 10. Damage, HP left 10. Hit points, hit points, hit points. Greater than 0. Continue going. Oh my god, can we go faster? I think I let it run for too long. Let's do this. Let's try that again. And then stop it there. So I don't have like an endless wall. Damn, that quickly went ham. Alright, there's our countdown. Player 1 took critical damage. HP left 10. HP normally should be. Wait a minute. I'm dumb. Okay, so it's my math. This is why I pays to know math and pays to drink some coffee because we gotta adjust some stuff. We don't actually subtract. We're just basically setting equal the hit points to the damage, which was a stupid thing to do. What we need to do is take player 2 dot hit points and then subtract the hit points from the amount of damage that user is doing. That's what we're missing here. Same thing here. Same thing here. Kind of, but this is player 1 hit points getting subtracted. And player 1 hit points here getting subtracted. All right. Some of these things come with programming. How do you debug stuff? It's experience. In college, in university, computer science class, you start to really struggle, and then you realize for every 1 hour I can write a program, I'm gonna spend for every 1 hour, probably I spend like 6 hours, like, especially in the beginning. The beginning of programming is you're looking for what's wrong. You're not going to notice it right away. You're going to be hunting for all the details, debugging, printing here. What is this variable? Why isn't it matching to this? It's a good reason I started printing all this stuff out too, so I can actually see what's going on. So for every single hour you create a program, that hour is going to translate to about 5, 6 hours of debugging, figuring out why it doesn't work. The best case to actually flow with programming is to debug as you go. Print stuff as you make new lines, make sure they're being connected correctly, and then make sure that your math is right. Player 2 wins. Nice. So, player 2 took critical damage, HP left 90. Player 1 took damage, regular 95. Player 2 took critical, player 1 took critical, player 2 took critical, da 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 da. Regular damage, critical, critical, and eventually player 2 wins. The randomness now is based on is it always going to be player 2 that wins? That's why we have that critical chance. Player 2 wins. Player 1 wins. Player 2 wins again. Player 1 wins. So now we at least have this randomness in our process. Had I not have a random and critical chance, then we probably have the same player win, and normally it's whoever starts fighting first. Whoever punches first with the same damage eventually takes the last hit. Oh, wow, what the heck? Oh, wait! Both are dead? That actually happened? Nice. Okay, that's cool. Both are dead again? Player 2 wins. Player 2 wins. Player 2 wins. Player 1 wins. Player 2 wins. Both are dead again. Well, I'm glad I programmed that particular case scenario. I didn't figure that was going to happen. All right, and that's how you use classes. This is all of the skill sets together in one. Variables inside of objects. How do we manipulate mathematically? How do we create all the pieces we need? And that's it. Welcome to the first 15% of all programming. And that only took us about less than 70 lines. That's it. That's it. You understand this, and you can rerun this. You can go over it again, and make sure you ask any questions if you're in currently watching and you need anything answered. But you rerun this a couple of times, and you see and understand. End of story. You will understand not only what GreyScript is, how that works, at least the basic components, right? The next steps would be to go into the manual. What are sines, tangents, dot code, that has index? Your understanding begins with the first 15%. Now going through all these extra bits and pieces and methods of programming start to become much easier to understand. You can basically read documentations, APIs, libraries. And when you see a dot in the beginning, right? Here's a dot. What's this dot attached to? Or is it list functions? Yeah, what is self dot has index? Where is that? I think it's strings, right? Yeah, strings. String dot code, string dot has index, string slice. You can take strings into spaces, smaller pieces, but whenever you have a string, aka hello, that's a string. So this string, you can say this is a string dot slice. It's one of those functions for strings. They exist inside. Then we expand to the 85%. And that's for another day. We take what we know, we expand it, but I'll keep it nice and hour and 12 minutes. That's not bad, right? It's not bad. All right, guys, make sure you like and subscribe. I've got other videos again you can check out. If you want to go more into realistic, real life programming, try out the Demystifying Programming Part 1 under my channel. Subscribe, like, notifications, all that jazz. But this is what's going to really give you the real life experience between knowing different languages, how they function. It's really all the different formats. There's two formats. There's a curly braces, and then there's the tabs. Two ways to basically organize your code. They serve the same purpose. I'm gonna drink some coffee. Stock market's about to open up, so I'm gonna do some data analysis and some graph trend stuff. If you want to know more about that, maybe join the office hours. And I'll show you a little bit of stock markets too, and potentially improve on analysis. Anyway, I'm babbling now. Thanks for joining.